Hello YouTube viewers, welcome to my channel Science or Technology. In today's show, Future Friday, we're going to talk about Varanasi Ropeway. So let's dive deep into it. Now, I'm going to focus on the ropeway itself. So, what exactly is the problem that we need ropeway to solve it? Well, reality is there are many cities that are old. To give you a context of it, how old I am talking about, Kolkata, it's a very important city. During East India's occupation, as in East India Company occupying India itself, it was the capital, not Delhi. So you have to know that some cities are old, ancient old, as in like Varanasi, yeah, it's ancient. So many cities are ancient, meaning it cannot be redesigned, meaning you cannot move the borders, you cannot just like, oh, we're just gonna displace people. No, like ancient cities, yeah, no. Even dictatorships have limits, like no. So fundamentally, you have to know they cannot be touched again, so to say. Now, population growth in those sort of cities generally has outpaced transit systems, meaning the roads and gully that we used to have, like small roads and all that, those was designed for carrying hundreds of people. Now we are putting 10,000 people per hour through it. It's like, bro, can't handle it. Roads can't handle it. Transit system can't handle it. It's like a whole system comes to a stagnation or congestion. So that's a really bad situation. Now, what can we do to save it? Well, public transit. The more people using less amount of space to travel equals better. Public transit is the solution. That's awesome. It will reduce congestion. It will not eliminate it, but it's like, okay, you have very high blood pressure. How about mild blood pressure? It's like that. So it's like, so we can do that. Now, what are our tool set? Well, awesome tool set is tunnels. Now, tunnels are awesome and amazing, but here's the deal. They are slow, meaning they take time like there is no tomorrow. Even if you smoke Elon Musk weed, please look how quickly he was claiming that he's gonna make a tunnel, and see first tweet when he's like, okay, we started to dig the tunnel, when it was actually launched to the public, you'll be like, damn, it's slow, like slow. And then it is stupidly expensive. So what is stupidly expensive? Well, to give you a context, take all the metro systems on the planet, any country, go YOLO on it, take all of them, combining them into a list. Basically metro systems that have actually paid off their debt versus metro systems that are running in red. Yeah, almost all are running in red. Almost all. Like you have to search very hard, very thoroughly to find a metro system that is not in red because cost is so high. If you ever wondered how the heck a nation could have a debt, right? You may think about it, like who the heck took that kind of loan, right? A nation could not have like 33 trillions of debt. Who the heck is, oh, look into transit system, you'll be like, oh, in like India has debt, like how? Oh, look into the metro system, it's like, I understand it. So these things are so expensive. Even if it will save the problem, it's like the best case scenario realistically is that even transit engineers are like, bro, you take a loan. Best case scenario, if the ticket sales are right, everything is fine, it's working optimally, you will get enough money to pay the interest, pay the maintenance cost, ongoing running cost. That's it. Principal, bye-bye. So it's not, basically it's not something that even if you want to do it, you would do it. It's like idiotically expensive. So tunnels are out for majority of places. Then we have trams, like it still has metal wheels on metal rails, so it still has the efficiency of movement. But what if you are talking about old cities? And again, would you lay down a new track and push off everybody who owns a car? Yeah, not a good solution. And be mindful, many old cities were not designed for it. They were not designed around the tram. They exist already. So your tram cannot just take a 90-degree turn. The turn have to be wise. But what if your roads do not have that? How many houses and buildings you're going to demolish? So fundamentally, this is also, especially for congested place, this is like no-go. Then you're like, what about elevated railway like Delhi Metro or Kanpur Metro? Now, these things are awesome. That is true. However, they still have huge footprint, meaning their footprint, how much area they take, it's huge. And because again, you are talking about railway, you're not talking about like, yeah, I'm going to do and do a Tokyo drift 90-degree like that. Like it's a curve. That curve has to go through things. If you are talking about like if every place is occupied, only roads are empty, you cannot run them on roads unless road is exactly straight. It's not going to work. So it does require a lot of demolition, like idiotically large amount of demolition, or you have to build them before the city grew. So this is also an issue. And not to mention, let's not go into the cost part. So that is a serious problem where it's like, dude, we have a problem, but a solution that will solve it, we cannot afford it. Other solutions simply will not be implementable. So what the hell to do? So Ropeway. Ropeway is a thankfully known time-tested technology. We have been using this puppy for hundreds of years. People is very recent, but for industrial revolution, we were using this for transporting ore, bulk material coal. So we know how this puppy works. Now it has a very low land footprint, meaning you're just talking about poles, and very few poles can allow you to cover huge distances, meaning kilometers can be covered and you will barely have like 10 poles. So that's like very low footprint, and each pole itself is not brutal. It's not like I am like, this giant tower. It's like, bro, road. You can just, in an intersection, if especially there's a roundabout, you can just put a pole there. Nobody would even notice it. So very low footprint, not zero, but very, very low. It's not brutal. So and it has no gradient issue. Like whenever you're talking about elevated rail, God help you if you are in a very rough terrain. It's like if you have a lot of terrain deviation, yeah, no. Railway is like, railway's gradient tolerance is very bad. Like at best case scenario, people say 8% gradient. What does 8% mean? It's like you move one amount, 1/8 amount you can, and not 1/8. It's like 100 unit forward, 8 unit up. So what about this puppy? Well, this has 100%. What does that mean? That simply means if you move 100 units, 100 unit up can also be tolerated, meaning around 45 degree. This puppy is like, bro, me good. It can directly go 45 degree, and it can go even higher than that. But generally, that's how people talk about this, engineering firms and all that. This has 100% slope tolerance, meaning generally people will not be living in a place where this cannot crawl. Like that's why we use it in mountain ranges. So this is like, bro, in 3-dimensional freedom, this is like, bro, I got this. Now, a much lower capital requirement, meaning this is a system that places like Mexico can build, and they invested in it, and they were like, holy damn, we built a system and it worked, and we did not added bankruptcy charges to our country. How? That's the difference. Like, is it so super cheap? Well, if a normal individual look at the price, they will get a heart attack. But here's the deal: if you compare this price tag to metro, he will be like, bro, take it and go. Take it and go. It's free. I will not even charge you. It's like, that's how big difference is. Capital requirement is brutally low, meaning Jeff Bezos can actually build 5 or 6 of them. Like that's how, and it won't even affect his bottom line. If it touches metro, if it touches metro, he'll be becoming from a billionaire to millionaire. Yes, that's how expensive those things are. Space is easy. So this is much lower capital requirement, and it is very quick to build. That's also another amazing part of it. Tunnels take long amount of time. Construction of that magnitude that is required for elevated rail, it's expensive in terms of time, meaning you will start like 5 years, and then you're like, okay, 5 years later, okay, 5 years later, okay. It takes time, like ludicrously long. These things can be planned, if done correctly, can be built inside a year. If like a large project, it still can be done in few years. Like it's very fast compared to all other systems. This is like fast. Now, on top of that, they are very quiet, meaning when you are talking about rail on rail, you are still talking about metal on metal. That puppy is loud. And if you have watched the movie 7, there was a very interesting scene. You had basically a giant subway above grade, as they say, train going there, and the houses nearby were very low cost. Like, why? Well, the whole house used to vibrate when you had train going on. This will not cost that. People, when they are in the ski resort, like they do not hear it. It's so quiet. Like unless you are right exactly where the pole is, where you are getting that metal wheel going on top of that clamp, you will not hear it. So it's very quiet. So that's also a good thing, because it will not cause hassle or harm to people living in the neighborhood. Good. And it's much easy to turn. Now here's the deal. Can it take 90-degree turn? Not really, but you can. So you have a loop and you let the loop go. Loop is like, bro, because of the hook design, this is the hook. You can have a wheel here. Okay, no problem. Everything is fine. Butter, no problem. But here's the deal. What if you have to turn it in this direction? Basically, if you want to push from here, you can't. So how the heck you gonna turn it? No problem, you just disconnect it. So modern systems, modern as in anything made after 1990, they figured out how to make a clamp on that. So the cable is free riding and you have a clamp. So clamp engages when it's coming through a bend, the cable goes back, the cart, the gondola goes to another cart, cable snaps onto it, goes ahead. No problem. And this also allows you to, like in old days, it was used to be welded. Nowadays, you can just detach it. And again, you can take it out, maintain it, service it. And if you have very high winds, you can just remove the, like empty out the whole circuit. So, and you may be like, wouldn't this require a person to get out? No. That's how fast it is. Like most links where you have that cable going and disconnection happening, this happens at full speed, meaning if the link speed is 6 meters per second, it will happen at 6 meters per second. You will not even notice it that, oh, you changed from loop 1 to loop 2. This is live. You do not worry about it. So it's very easy to turn. So if you have a, like, let's say a crossway, right? Let's say you have a line A coming from road to road, you are happy, everybody is fine, but you need to cover this part which is 90-degree offset to you. You can just have a joint like this. You're like, okay, we're gonna tear that. And you will not be like, okay, I need to destroy so much area just so I can get a gentle curve. It's like, bro, I got this. So it's much easier to turn and it blends with the flow. This is, and again, it has the clearance not only in 2-dimension, it also has 3-dimension freedom. So it's very easy to flow. That's why we use it on mountains. It's flow. So this is the ropeway. Are there limits to this awesome technology? Well, yes, you have to understand that. One of the greatest enemy of this technology is high-speed wind, meaning if you want to build this in America where there's a place known as Tornado Alley, yeah, no, sir. If you are in a place where you have very high gust of winds regularly, yeah, this will be off most of the time. So that you have to understand. And be mindful, engineering wise, these puppies are designed to be like, if randomly event changes so and people were in the gondolas, it will survive it. But here's the deal. You may not want to be inside it. Again, this is designed, engineered to withstand those things. It will like, bro, I can survive you. I can safely take you down. You would not want to be going like this in midair. You do not want to be like that. So for that reason, for safety reasons, we are like, hey, high speed wind, that's its weakness. Snow, not an issue. Heat, not an issue. Winter, not an issue. High speed wind, that is an issue. Rain, no issue. So it does have that limitation. If you are in a place where you have a lot of high speed winds, yeah, that is an issue. Another is that unless you have multi-car pod, meaning generally most of the designs that you see is single cable. You have one cable, that's it. Multi-cable does exist, like in this scenario, some European country, I do not know which country has this, like they're just showcasing that we have too much money. It's like, dude, how the heck you have such a huge gondola? And again, it has multiple cables and one pull cable. This is what we call cable car. So these things are huge. Then you can have almost a bus like. They have an open canopy in this, man. It's like somebody was like, allow me to show you how much money I have. It's like, this is bonkersly expensive. Most places do not do this. This is like, bro, wrote a blank check. So unless you have this, where you have multiple cable, the pods are very small, meaning you are looking at best 5 to 15 people. That's the zone. That's the sweet spot. Can you make it bigger? Not really, but like that's the sweet spot, 5 to 15 people. So that's the limitation. What does that mean? Having a pod that only has that, because again, be mindful, you can be detached to the cable. So what's the penalty? Well, penalty is the throughput, meaning how many person can be moved from A to B per hour, per direction. It's much lower. Like compared to a metro system, it will be at least 10x slower, like exponentially slower. And what about speed? It only goes to 25 kmph. Now, like, wait a minute, isn't that super slow? Not an issue, because of the way these are done, you actually going from point A to point B. It's almost like an airline. You can see in the map, it's like A, B. It does not do a lot of turns, and even though it can do, generally we do not need. So 25 km per hour is not that big of an issue. You will be comfortable, you will be fine, you're going to get your place fast enough. Especially if you are in a congested city, you're like, shut up, take me into this. 25 kmph continuously moving versus start stop traffic, shut up, take money. So, and there is a one issue. If a city becomes dependent on this sort of thing, maintenance is an issue. Unless you have multiple loop, each loop is reliant on one another. That's in those sort of scenarios. If you ever have to replace the gondola, not an issue. You will not even notice it. They can remove it from circulation, service it, bring it back, not an issue. Every time they need to repair the cable, yeah, that's an issue. That's a big issue, meaning the whole link has to be turned off. Some like in Mexico, they have been doing this. So in those situations, they could take off the whole link, but it's not like a metro. It's not very easy. That's a penalty, meaning you could have this system which shuts off every let's say 2 years or every 3 years. But would that be good? Here's the deal. Which system have you used that has never ever had an issue? Heck, planes have cancellation. So it's an acceptable downside. Now, one thing that modern people will have issue is that they do not have power, meaning these puppies do not have a way of getting power. Why? Well, even if you have one cable, you have floating. You are floating. Even if it has high voltage, all you're going to get is high voltage. You're not going to ground yourself. So you do not have a way of dumping energy into it. This may have multiple wire, but even I doubt this. Like, it does not make sense. So I have not seen any design where they can have power to it. So how can you have power into it? Well, you can put batteries and solar panel. That's the only thing I have seen. And older designs, that's why they were open. Like, there was no other thing to do. So power, there is no way to dump electrical energy into this. So if you need to run it air conditioned, yeah, no. If you need to run USB power charging, no. So battery, solar panels, that's the only way I can see of providing power, given the fact this has solar panel. So there are certain limits to it. So are there any unique selling point if it has that kind of limitation? Well, this is one of those things. It becomes a tourist attraction on its own. For example, some place in Britain did something very weird. They just copy pasted a metro link with gondolas. It's like, what's the point? Nobody who was using metro switched to it. It's like, why wouldn't they switch it? It's like it's going in the same place where metro is. So, but it was still in use. Who was using it? Tourist. So it does become a tourist attraction. And yes, if you think tourism does not add money to it, yeah, no, tourism add money to you. So if you have something that it itself becomes a tourist attraction, that's like, shut up, take money. It will add money to you. So it does become tourist attraction, which for many cities is like, shut up, take money. Then if mass transit is not viable, which is the reality of most places, especially if upcoming economy, where they are like, dude, we were not rich enough in 1800s where we had tunnels, digging machines, or like, oh, we built our first metro 100 years ago. If you are not in one of those places, what the hell are you going to do? You grow, let's say in last 20-30 years, you can't afford to bring a national level debt to your small town or like a growing city. What the hell are you going to do? You can't afford metro. Again, even elevated system will cost too much destruction. What the hell are you going to do? So in those sort of things, if conventional mass transit is not viable, it's just not viable. Like you can do all the studies and all of them are saying the same thing. We cannot do this either by cost or by congestion. We cannot do this. What the hell to do? And this is a real world issue with many places that are second tier. Like first tier, we already know they are dead. But what about the second tiers? They are also going in the same route. It's like we are stuck. And anybody knows anything about anything, they know this one thing. Inaction is the worst action. You should not ever be in inaction scenario. So having a system that does not have the throughput of, let's say, a metro line, that's okay, as long as you have something. It's like people are going, many politicians suffer from this, where they're like, I want metro. It's like, dude, don't fight for metro. You will not get the budget for it. It's like, no, but metro has like this many throughput. It's like, you will not get it. And if a country does give you that, you will cause bankruptcy. You will cause food prices to go up. Why? Like, use this. It's like, again, it will relieve pressure. It will not solve the problem, but it will relieve pressure. That's better than nothing. So it's a perfect fit in those sort of scenarios, which for tier 2 cities is compulsory nowadays. It's like, and here's the deal, if you do not have mass transit early enough, people get addicted to cars, then it's God help you. So you have to make sure people do not get addicted to vehicles. That's the first line of defense. Do not make people addicted to vehicles. That's the sole reason why Europe and Japan has such a good infrastructure, because they invested it early enough. Japan lucked out because they did not have finances, so they had to invest in metro and infrastructure project, because again, it helps in two ways. Like, you are investing in the economy, that itself boosts itself. So it had helped. Europe was very early built, so everything was designed for human first rather than car first. So they lucked out in those regards. But other places, they are like struggling, like India. We are struggling with traffic. So if you have a scenario where you have very good bridge connections, meaning A to B, which only few people uses, but they use it regularly and drive to it, at least remove that much. Removing any amount matters. Removing something regularly, reliably, especially for a growing city where people are, rather than, hey, what if I use my car daily versus I'm going to use it, or I use my car on Saturday, Sunday. That's a good thing. Safe, awesome. So it's great for in-between links, and given the fact that it can cross a river at the cheapest price, shut up, take money. If you ever have a river as a blockade, this puppy is the cheapest thing and more reliable than any other option. Like if you have a cruiser, yeah, it's not very reliable. So this is really awesome. Bridge links, shut up, take money. And it has its own right of way, so it bypasses the biggest issue with other mass transit system, like especially with trams and trams and buses, is that you do not know how reliable they are, because they are only as reliable as roads. Meaning, if road has traffic jam, God help you. This has its own right of way, so it gives you that same reliability a metro system can give you. Whereas, like, no, it will come at 6. Okay, it came at 6. I sat at 6. I stopped at my station at 6:15. I went to my office at 6:30 when I supposed to be there. Everybody is happy. So that's a really good thing, and it's amazing for steady trickle flow. If you have this criteria met, basically, let's say you have a town and you've noticed that from this halt, right, let's say this point, hotspot, a lot of people go to this, but it's not too much where you can justify basically a metro link, but it's enough. Like, enough people go regularly. In those sort of scenarios, this is like shut up, take money. For example, if you have metro link, right, and you have an airport outside of city, building the metro itself to that location, it will make sense. It, like, from a speed point of view and from construction point, it's like, we have the tunnel, might as well just dig there. But if you have stopped the system, yeah, good luck. It will take way too much money and all that. In those sort of scenarios, like, hey, just let's say it's only 3 kilometers, put a gondola there, And you may like, it does not have throughput here. Still, how many people actually just go there? Because be mindful, a plane, single plane generally carries around 100 to 200 people. On jumbo jets, maybe 500, 600 people. So it's like, it's not that much. And if your gondola has 1000 per hour, you're good. So it has the trickle flow available, meaning you have a tourist spot, a convention spot where a lot of hot spot goes to that spot, lightweight spot, regularly, shut up, take money, build this. And it will remove so many cars from the street. So that's the whole point. It's amazing technology for mid-city. Mexico realized this very early on. They're like, dude, this is good. And the response from public were like, holy damn. Like a mid-tier city went from like, to like, damn, we good, we grow. It's awesome. So, and it's a very good solution for hyper-congestion without destroying the whole city. So it's really, really good. Because again, cities have lands that are preoccupied, meaning you do not want to do this. It looks very American because it is American system. It's like just a road taking over such a large area. It's car-centric. You want people-centric first. So fundamentally, we do not want this to like just happen on railways and all that. So it does have some very serious USP. So let's talk about the India's first mass transit ropeway, that is Varanasi Ropeway. The work started on March 2023, recently, and it's supposed to be finished by May 2025. So it should be finished by end of 2025, hopefully. It is a public-private partnership, PPP, with Berthold, which is a European company that specializes in making gondolas, and which was Samundar Engineering Corporation, which will be responsible after it has been like acquired the assets to run the asset in India for 15 years. So it has two lines. You can say A line, B line. Because again, while the link gondolas can literally go from here to here, the cables won't. So you will have a motor A here, motor B there. So you have two lines. Total 5 stations, A, B, C, D, E. So you have 5 stations and it's supposed to be running 16 hours a day. So I know that they have a light here. That's why I'm pretty sure it has a battery. And the total length, if you stretched it, is around 3.7 kilometer roughly. So it's not designed to be super duper long. You can make them, but not recommended. So 3.7 kilometers. Now, first motor that is taking care of the large leg, it's around 560 kilowatts. The smaller leg that is like a bit lengthwise is much smaller. It's 415 kilowatt. So for the amount of people it's gonna move in terms of megawatt, it's lower than freaking electric cars also, like exponentially lower. So really good system with that. And it has only 18 supports for this leg. That's the critical aspect. You cannot do anything like, not even a highway in 18 supports for this sort of length. So 18 supports here, and B sides only has 11 support. That's another aspect. How much destruction there has to do to go through places, it's very minimal. Not zero, but minimal. Like it will look zero to outsiders. It's like, hey, you only destroyed like, 15, 16 places. So it's very rare. And the windows are IR coated. Now, I do understand. Europeans, they understand winter. So for them, these things are easy to build. It's like, bro, people are already in their winter clothes. We have to close it. Everybody is cool. In India, it's like, dude, if we did that, people will die. It will become hot pocket. So it does need IR coating. It does have windows. I'm seeing some way to open it up. So I'm pretty sure it would need some fan to circulate air otherwise, and it will need infrared coating, reflector coating. So instead of using UV coating that is used in high altitudes for mountain climbing, it has to use basically infrared coating so it does not heat. So let's see what happens. But fan part, I'm not sure. It would need it, I'm pretty sure. Even if Europeans, they just sell it here, I'm pretty sure the Indian engineers are like, dude, just put a fan here. Otherwise, nobody will use it. So that's how they're going to work with this. So this is the first approach. And if this works out, I can see amazing things happening afterwards. Because again, this is like solving a problem where it's like, dude, all other options are either not going to work or going to bankrupt us. What about a mid tool? It's like, dude, it will not solve all our problem, but it will solve some problem. I'm very happy with those sort of options where it's like, okay, no good options exist. What is the next best? You have next best, let's go with that, rather than stuck on nothing. So I'm really happy with this sort of approach. So this was my presentation on Varanasi's Ropeway. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.